Hello, everyone. This is Linda from ModelOp. Thank you all for attending today's first session of the ModelOps Technical Master Class. Before we begin, I would like to cover a few housekeeping items. If you have any question during the masterclass, you can submit it through the Q&A widget in the WebEx interface. We will try to answer as many questions as possible during the masterclass, but if a fuller answer is needed or we run out of time, we'll make sure to follow up with you in a separate email. A copy of today's slide deck, the registration of this masterclass, which is recorded, will be shared via email after the masterclass. This is the first of a cycle of 5 sessions, so feel free to send the invite to your peers or colleagues. But now, without further ado, I'd like to hand it over to Jim Olsen, our CTO and a recognized visionary in the AI space. Jim, over to you from your beautiful cabin.
Great. Thank you, Linda. Yeah, if there's any glitches, I'm actually off-grid, the cabin at 10,000 feet, so we're running over satellite. Works well most of the time, but see any weird glitches, it should come back on that kind of thing. So I think we're all working in different spaces, and I'm really glad you joined me today to go through the first in this series of 5 masterclasses that we're actually going to be doing. So today is a little bit of kind of the setup for all of the other ones. It's an overall just introduction to the ModelOp Center, our product. We're going to go through and show you a little bit about the reason why we made it. All of these classes, I'm going to keep it real slideware light. So I promise we've only got 3 slides today. The rest is going to be hands-on live demos. The other ones will be the same kind of format. I don't want to just show you slides. I want to show you the product and how you work with it and what you do on what it is. But we do want to take today's session to kind of show you all the bits and pieces so that when we dive deep on some of these other topics, you'll have some perspective and relevance as to what the heck we're doing with those individual items on there. So today's session will be that overall introduction. I am going to just mention the other items that we're going to be doing here. The model catalog, we'll go into today. We're going to dive deep around how we actually describe AI models and even non-AI models, just your standard statistical models or other kinds of things as well. Then we're going to talk about model runtimes in the next class. How do you actually enable your models to be monitored, and how do they actually run on different kinds of runtimes that are available out there? And then we'll be explaining the model lifecycle today and what that means to us. But then we're going to dive deep on actually building one together and then how you incorporate that with you enterprise. And then finally, we're going to look at, okay, now that we've monitored these models and deployed them and all of these different kinds of things, how do we actually go through and measure what we're getting out of this whole process? And we'll be diving deep and specifically with Tableau to pull data from our system and how you can interact it and chart all that stuff. So all of those are going to be very in-depth, hands-on style items. So today you get a little slideware. Next time there'll be less slides and more just hands-on, but we will be doing a live demo here of this. So one of the reasons I just wanted to start with this one slide to talk a little bit about why we're doing what we're doing. We've seen out there time and time again within different enterprise situations that people are struggling to get the models from the data scientist's desk all the way out into actual production. And the systems, and then monitor them, and how do I make them reproducible so that I know what went into these? How do I deal with all the cross-organizational aspect of all of that kind of process of reviews, approvals, required government reports, all kinds of things that go on with models. And when we looked at conventional software and DevOps, there's definitely some tools that can be utilized to help in some of those processes, but they really fall short on the unique kind of challenges that you actually have when you're dealing with models, data that goes into models, reports and monitoring and things like that. So we really needed to look at a unique approach for how we deal with models at scale within the enterprise. So doing that, we realized there was a huge missing piece in the middle of all the items. There's lots of different model factories out there, a large variety, and depending on what kind of a model you're actually developing, there's going to be different choices. There's plurality of them likely in your enterprise on that kind of thing. So, there's items that actually deal with like just the data wrangling side of things and model catalogs and things like that actually do that. There's the actual data science workbenches for developing these models and that kind of things. And then those vary greatly depending on what your kind of model you're doing. If I'm doing a straight R model, which are absolutely still out there in the industry, heavily being used, versus excuse me, a new like AI type thing where I've got to go through and retrain and do hyperparameter tuning and all kinds of different things. Neither one is going to address the other one very well, and that's why I say that there's likely a plurality of outcome that you're going to need to use within your item, as well as the actual tools and tooling, et cetera, to make sure you're landing data and ingesting data for use and training and all of that kind of things. On the other side was the actual apps that are out there in the business, whether they be a GUI front end, a report that gets run once a month, or some kind of an actual live decisioning system, rerouting people based on the experience they're having, or perhaps the credit fraud detection process. They need to get actually deployed out there in a consistent manner. And what we found was there aren't a lot of great tools that sit in the middle and provide that progression from these great data science workbench tools and model factories that are already existing out there, and getting them in a consistent pattern out to the ultimate deployment. It's a hodgepodge of things. Sometimes it's a manual process. Sometimes there's some custom-made scripts and things that pull things together. But where we really sit is this area in between, and I'll continue to point that out as we go through the actual live demo. We're not trying to replace the data science workbenches. We're not trying to be just the consuming apps that you have to use us. We're that bridge that actually shepherds it through the whole process within your overall enterprise and gets it from the data sciences and desks and workbench and stuff and gets it out to those consuming apps in near real time. And we additionally want to be able to actually have the governance of cataloging the model, what went into it, have the auditability of, who approved it when and all that kind of stuff, as well as the interpretability of what into the models, as well as actually having consistent methodology for the deployment process. And that's going to be different, as we'll show you, for different kinds of models. And then also monitoring once we get it there. How is it doing? Does it need attention from a data scientist? And if so, how do I get out there and actually inform the data scientists that they need to go look at this and get them the information they need in order to make those kinds of improvements to the model? So that's really where we kind of set up. So the final slide, where we actually jump into real software and start looking at live. And I know it's a little bit of an eye chart, but this is the overall architecture of the system we're actually going to be looking at today. So, we'll actually have, this is all running live under Kubernetes. It's a local instance in this case that we're running on today. And all of our software is container system agnostic. We do actually utilize a containerized system. In this case, this is going to be Kubernetes with Docker. But we have them deployed on other things like OpenShift and Blue Data and other things as well. So when I talk about using Kubernetes today, we think that's a great platform for deploying a microservices style architecture. But keep in mind, we're agnostic to that. We can do on-prem, we can do it in the cloud, we can do it, frankly, on bare metal hardware if we wanted to. I think this is a more manageable solution, but there's nothing in our architecture preventing any of that kind of things. So at its core, we built this around being a true microservices architecture. So we're utilizing Netflix's Eureka, their open source version, for actual service registration and balancing. Every single service is an actual true stateless microservice, so you can scale any of these items. We only have one running in of each instance today on this particular machine, but they scale horizontally in that you can bring them up. The actual Spring Cloud gateway we use for dynamic routing that listens to Eureka and routes to the individual service providers through the common front end. It supports many different kinds of load balancing strategies between those, so you can dynamically bring each of these individual items up in a plurality and scale horizontally on that kind of thing. So as I just mentioned, we use Spring Cloud Gateway for that functionality. And we also have installed, we'll be using an Angular-based application today that we call our ModelOp Center, where we actually provide interaction with that, as well as we expose a full, basically RESTful RESTful API to actually interact with our services as well, so we can integrate with additional solutions. We'll be showing several of those integrations today as how we do it. So we'll have a model manage instance. That's kind of our model catalog we talk about. That stores all the central information. It utilizes Mongo on the back end to actually store that information through a standard connection. We use Spring and Spring Data REST to provide that implementation. So you can filter by anything, question by anything, and do that as well. Now for actual source code assets and stuff, we actually store those in Git, and we'll be showing several styles of Git integration today of how we can interact with that. And basically, that allows us to have a proper version repository of kind of our source code assets and things like that. And we'll be talking more about individual different kinds of assets as we jump into the demo. We'll also be showing some integration with a few different data science workbenches today. We'll be showing Dataiku is one of the options and how we treat that in our system. And we'll also be showing Jupyter notebooks as far as being able to interact and develop models with those, as well as just directly interfacing with the standard GitHub as well. For normal if you have a different workbench you're using and you store them in Git already, we can interact and provide a consistent view across all of these different model factories. And that's one of the key items that we really do is we're not tied to any one workbench. Instead, whatever factory you want to use and processes, we're going to work with those because everyone's made investments in different areas on those as well. Won't be showing it today, but we also do RStudio, for example, is another one. And those all interact with Model Manage. And we're going to be talking about runtimes today. Again, we're going to be showing two different runtimes today. We'll be showing the ModelOp runtime. We provide one that can run a plurality of different kinds of models. It can run R models, Python models, PFA models, C models, Java models, TensorFlow models. It can run a bunch of different one of those, and it's pre-enabled to report statistics back to us, which we'll be showing you as well. Additionally, we've integrated a Dataiku runtime, as well as we have like a Spark runtime and some other ones as well. So we can actually enable existing runtimes to report to our infrastructure because we have everything enabled over WebSockets using standard APIs, et cetera, to be able to provide that information. We'll also be showing integration. Excuse me, let me go back one. We'll also be showing integration with Jira for providing a ticketing solution for how we actually do workloads and stuff. Again, we've taken the approach of embracing multiple different items there because you're not going to replace your ticketing system within your existing enterprise. We also have a centralized reporting service for actually showing the live statistics and stuff you'll be seeing. That's all built around WebSockets, and it's used internally and also externally by the application. And we'll be spending a bit of time talking today too about our model lifecycle server. And I'll go more into that when we actually get to it because it'll make more sense there. But it's basically what manages the actual shepherding of a model from the data sciences workbench or model factory all the way up through the different steps that it must do within the enterprise. But it's done in a way that leverages Camunda as a BPM solution to actually let you as the enterprise owner design your unique process for that. We've done that by creating a series of different tasks, triggers, and services, which we'll demonstrate today, that allow you to drag and drop and build up the flow and the steps that a model must go through. And that'll make a lot more sense when we do it. So that's kind of the overall architecture of underneath the covers of what you'll be seeing live today, just to give you that kind of perspective. So it's a very hyper modern architecture that covers the microservices oriented approach to that. So up out of the slideware now, as I promised, and get us to the real items here and just refresh our page. So what I'll do today is kind of start out by walking you through kind of some of the different features as introductions to the follow-on classes where we're going to dive really deep on the individual subject matters and actually build things. Today is to give you that perspective of, okay, when we build this, what the heck is it actually doing? It's good to have that level of perspective behind us on there. So overall, as I said, this is our Angular application. It's called the ModelOp Center. And it provides us that kind of overview of stuff that's going on within our systems. So you can see, for instance, there's a large variety of different notifications that we actually have that have been running and things like that, and we'll be interacting with those soon that provide us the information. But we're gonna start out in kind of paralleling a little bit here the course structure. We're gonna start out by looking at the models, because it all starts with models and they all come from the model factories. So you can see here, for instance, we have a bunch of different models that these items were actually imported from Git, like I talked about, but we also have ones imported, for instance, from Dataiku. So if we were to go take a look at one of these Dataiku models, for instance, we have some consistent format of describing what models are, and that's what we'll dive deeper on in the next session, as to how we've managed to abstract models so that we can describe them, whether they're an R model, a Python model, or frankly, even just a decision table, and sometimes needs to be treated like a model because it's making those critical business decisions. And we need to know when people change it because it can have an impact on your business. So we've developed kind of this overall higher level data structure that lets us describe, no matter what kind of model factory you have, gather those assets and resources together in a consistent manner so that we can then reassemble the model on there, but also have some traceability into what's going on there. So we can see, for instance, this is a Dataiku model. We can see the source behind any recipes that are defined within Dataiku. And in fact, we track the metadata behind where it is, so we know the specific project that was done within Dataiku and the recipe and all of that kind of information as well. So we can abstract some of that kind of information out. Additionally, we can know, how does this model actually talk? So what we've done is we've actually basically standardized on Avro to describe input and output schemas to the model, so we know what data structures that this model actually relies on. Avro being an industry standard, we just translate from whatever the proprietary format is of the individual model factory into the standardized format, so we can automatically plug data pipes together with models, or plug model to model, and know that the contract is there of you're outputting the right data, so the next guy has the right input data and that kind of thing as well. So we can pull that. So you can see, for instance, here we have the basically the fields described for the actual input schema in this case, just being simple, an integer ID, and the content is actually a string, and it's a single record. And likewise, we can see what it puts out, which is actually the same. So it's not that spectacular there on that kind of things. So when we go back to, let me go back here. We go back to that. We also capture information about the model factory itself and what this was developed on. For instance, this one, we can see it's a Dataiku model. So we have the information here about like the project, the individual schema representations and data sets that it expects, because Dataiku provides us an input and output data set is typically what we deal with there. So we have the information about them. But more importantly, we can get right into the model factory and actually go in there to actually interact with that model and go into that environment and do it, assuming it's a web-based solution. Otherwise, it'll take us to Git on that kind of things. But then we can go and find out more about the model within that particular environment as well. And we'll be showing Jupyter as well later on as part of a kind of a demo walkthrough of a day in the life scenario, as we like to call it, where we show actually walking one of these models from the model factory all the way out to production. And additionally, there'd be attachments information. So let's look at a slightly different model here. We're going to grab our let me grab my one here. And so like if we were to look at this model, it's an XGBoost model that we're going to be looking at here today as well. You'll notice that, for instance, we also can have the concept of attachments. So in this case, there's a model file that's associated with this particular attachment, and we have it stored out within S3 in this case, and we provide that kind of ability to do that. So you can see how we build up this whole kind of overview of a model. It's there. Now we've only shown you kind of some of the higher level information we gather. What we'll do in that next class is we'll actually dive deep about how do we actually store all these assets? How do we translate from the different model factories into this data abstraction? And more importantly, how do we reassemble them back, and how do we track them and things like that? That'll be that kind of that follow-on where we go through in depth on that catalog. Now, once we actually have these models within the system, the whole goal is to basically move them through the business in a consistent manner that is basically governable, traceable, and has governance behind it, and is reproducible on that kind of things. What we've done is we've come up with what we refer to as the model lifecycle. Now, the model lifecycle itself is this process where you can define what actually the steps that happen when a process starts. So for instance, we have one here that's running in the background that basically is a backtest implementation. We can see it running right there where it's going out. It's checking if new data, new ground truth has become available for a model. And if it actually has, it'll actually run a new test against that model on one of our runtimes. And we'll show you that in a little bit here too. And actually check and get the scores. With those scores, the neat thing is we can do is through this process is we can use decision tables to actually determine whether an alert needs to be generated that somebody needs to go look at that model. And we'll be showing an example of that in that day in the life walkthrough I was talking about. But more importantly, we can define actually how we move the model through the process. And actually, let me bring up this tool here real quickly. It's going to let me come up. Come on. Oh, there it goes. Basically, we have the ability to drag and drop define basically the process. I'm bringing this one up because it's a little bit easier to see here on that kind of things. Now, this is Kamunda's modeler tool, but you can, so it's a standard BPM implementation where basically we've extended it with our capabilities. So basically, what we're going to use this demo ridiculously simple process today in the interest of time, where basically what happens is when a new model is actually submitted for review, basically it's going to go through and it's actually going to, if it needs to be trained, it's going to train that model in a known environment, a reproducible manner. If it doesn't need training, it'll skip that part. And it's going to actually run, again, a consistent test against the data that's out there. And it's utilizing our system and our drag and drop methodologies to be able to do that and run the test and actually put those tests into a consistent report, which we'll be seeing in a bit. And then actually go out, it's going to create a notification within Jira to go review this. So we're going to go over to the ticketing system to do that. And then once the Jira ticket has been created, it's going to wait for an actual person to approve that model by completing the Jira task. And once they either approve the model or reject it, if they reject it, it goes back, a new Jira ticket gets created and sent out to the original developer. Or if it fails the tests by the, like it doesn't even run or something, it'll also do the same on that kind of things. But if not, then we're going to fast track it, in this case, out to actual deployment on the business application, the real runtime engine. Obviously, this is a ridiculously abbreviated process for the sake of the demo, but you can imagine much more sophisticated, but more importantly, I can define this any way I want. So here we're creating a Jira notification. We also have one to create one in ServiceNow, or easy for us to extend this and make it into your custom ticketing system, whatever it is. We've built all of that kind of flexibility in there. We're using our engine today to run them, but there's no reason those same jobs could not run on a different engine like Dataiku, in the case of a Dataiku based model, or a Spark based model, or that kind of things as well. So you have this flexibility to design the process, because what we find is, drop back one here, is that in reality, the processes within an organization look more like these guys. There's a lot of different steps. There's some A/B testing you may have to do. There's certainly probably a QA environment you run through first and let it run there for a while and have a gating item beyond that. And it needs to go out and actually review that down the line. And or it's got to generate specific government reports that have to happen and be mailed out and cataloged somewhere and get associated with the model and be able to be traceable in the long run on that kind of things. More importantly, depending on what the model is, that process is going to be different. So you can see here we have multiple different kinds of life cycles that we've defined, and can be done based on the target of that model, or a specific tag on that model. We support that as well, or it's a business unit that it occurs in, or all kinds of different ways of specifying which path that model should actually follow. Because if it's an actual going out into, let's say, you know, making a credit decision about somebody, whether they should or should not get in a loan, as an example, there's a lot of scrutiny on those models. We're going to want to make sure they're not biased. We're going to want to make sure that we have the documents to prove that down the line. We want to show the data that went into it. And, you know, maybe it has to be compliant with the Frank-Dodd Act, and the data can't move more than 3 times before it goes in the model, and I need to show that. But I have an internal forecasting model that I use, you know, more as information within my company that doesn't make those kind of decisions. There's no reason that, you know, I need to put it through that rigor. So it's not a one size fits all, and that's what we found. So by having the ability to deploy different diagrams for different kinds of processes, all these different model lifecycle processes, we have built in that flexibility. And also we get the abilities to, as I said, integrate with existing investments within an enterprise architecture, because the reality is you've already got a ticketing system, you've already got an email system, you already have a reporting system, you already have, you know, potentially a document store system. We need to be able to send our information into those environments. So, you know, we'll be showing that today a little bit with our Jira integration, but, you know, we can do far more because we built this stuff in from the ground up with this design. So it's a very unique design for how we can do that. So rather than being the strict rigid kind of flow you typically get in the DevOps, where, you know, it's like, yeah, maybe I run some unit tests, get staging, environment goes out. That's not going to be true for models. There's a lot more that needs to be done. We have that ability built into our ModelOp Center to be able to do that through these model life cycles. And that's what we'll be working through in the third session, excuse me, forgetting this one. The third session will actually be designing some of these, showing how do you plug in a different runtime and or a different ticketing system and or my custom thing I need to do. We'll actually be building some of these so you can get that idea of how you do that. We'll be using the modeler tool to actually do that, and we'll deploy a new one, because you can deploy a diagram directly from the modeling tool right into our system. So we'll be doing that live and diving deep on what all these little bits mean and what delegates we have, and designing up brand new ones from scratch on that, and deploying those live together. So I think that will be a great in-depth session as well. I highly encourage you to attend to learn more about these model lifecycle processes. Then finally, we have these concepts of runtimes we mentioned as well. You know, we have our own runtime, which we talked about with these different engines. These are the ones that are all like engine test, engine 1, engine 2 here, are our ModelOp runtimes. And we're going to dive deep in those in just a second to look at the kind of different things we can do there. They're great. They're pre-enabled to run all different kinds of models. They're pre-enabled to report the statistics over WebSockets, et cetera, and things like that. But they're not the only runtimes out there. You may have one you already invested in, or, you know, you may be doing something like Dataiku. So we've abstracted those two to actually be able to pull out the information in a consistent manner about the individual runtime and track them as they are. So we can see we have 3 sitting idle and we have 1 actually out there running. These all dynamically register through Eureka as well. So they can be brought up in groups individually, et cetera, for different roles, and they can be tagged. So if we go take a look, we'll go take a look at one that's actually running right now and that kind of thing. So you can see we have the concepts of tags behind them. So you can group them by that if you like to, or, you know, you have different roles and things like that. You know, we can see the jobs as actually run. And we can see some information about endpoints. Now, our runtime actually supports the concept of binding endpoints separate from the model. That's one of the advantages of our runtime. So for instance, we can see this particular runtime is actually bound to a Kafka queue. So it's processing records as they come in off a Kafka queue. We have a little generator set up in the background that's constantly posting records to it, and we'll see that in a second, just for demonstration purposes. But the idea is I could go in and, you know, the particular type of the actual endpoint, we could change that to a REST endpoint instead. Doesn't require any changes to the model at all. If you tag our things, and we'll look at that in a little bit more detail as well as to how we actually do that. But the idea is that you can actually enable these models to have this dynamic banding, so you can swap out the endpoint it's listening on from REST to Kafka to whatever without having to change model code. Or as you move it through different basically stages, we'll show you batch jobs in a second to just run tests on it, but also, you know, environment want to point to that kind of a portion of the data to do A/B testing through something like Kafka, and then not have to basically redeploy the model to that, we can actually just swap out the endpoint. You get a lot of power through that as well. There's a lot of capabilities on that. We can also query the actual runtime to see its different capabilities. So we know the libraries and basically the actual levels of the system for the different platforms it supports. This particular engine is only configured for Python and R right now. So we have that, but we do know the versions of the libraries and everything's there. And we'll show you how we can capture some of that information about the model too when we develop it, when we go through the Jupyter plugin, so you can tie those together on that. So you can say, hey, will this model even run on that engine? We have those kinds of capabilities as well. And then ultimately, we can actually monitor the model itself to see how it's performing. So we can see the impact on the system. We can see the amount of records that it's actually processing at the moment on that kind of things. We can see the system. But remember those model life cycles we talked about. One important piece of the puzzle is knowing how the heck did this model actually get deployed onto this system. And we're going to walk through a full life cycle is in the latter part of this demo here. Or we're going to actually do that and walk it through, and we'll see the results of the past and the decisions it took. We actually use those model life cycles to initialize the demo platform. So we kind of just eat our own dog food there. It's the quickest way to get it up. So we've actually pre-installed a couple of, we ran a couple tests. Back here, you can't see because it's an eye chart, but it's we ran a couple tests, and you can see where we did that. It's hard. WebEx is making me go slow. I'm going to stop trying to do that because it's going to make you dizzy. Basically, then actually put a couple of models and deployed them out on the engine through that. But we know exactly how this model ended up on this engine. I can see every step of the process, who did what, when, how, etc., to know how this got out here. And when we do our little day in the life scenario, that'll become more apparent, and I think it'll make a little bit more sense because this one's just the demo one. But that gives us a lot of power about something's wrong with this model. We can figure out who approved it, who reviewed it, who developed it, what tests were actually run on it, were they ever run, or we get audited. I have all that information in hand that, yes, I did generate those 16 required reports before this actually went out into production and was making those kinds of decisions. And we'll show them some examples where we can actually look at like bias reports and things like that we've cataloged before it ever made it out of production. So we have all the information available, and we know we did the due diligence before we put it into that position. And we can monitor the live process too as well of how it actually gets there. So that's the idea of the runtime. And what we're really looking at here in this case is one that is running a business application. It's a fixed endpoint processing things on a Kafka queue, putting the results back on the Kafka queue, and it's making those kind of real live runtime decisions. There's also the concepts of basically jobs where things are more done. We're going to look at some of these results on here where we have these idea of these test jobs that actually happened, where we actually track, basically it's more of an input file with an output file kind of things, like generating a standard report or generating test results, which is what we'll be looking at today, where we run some metrics on a model and actually pull those together. And then you can see here where, we capture the output and when it was occurring, time, execution time, all that kind of information. And, like any UI, it's limited in what it can show. We can track these over time. We can do all kinds of different things. And we know an awful lot about the model behind this run as well. So that's our idea of a batch job. And you can actually create these live, and we can run them not only on our runtime, but for instance, we could pick a Dataiku model and go run it on their runtime if we wanted as well. Our abstraction, again, holds true that we capture consistent metadata about that whole process. We're the conductor of the orchestra. We're not the individual player. Instead, we'll let the players do what they do best. We have a great player in our engine runtime, but we wrap the other existing runtimes as well, and can execute those items out there, yet still capture that consistent view, that single pane of glass across all of these different execution environments and model factories and everything that are going out there, so that we have that kind of information. That's really important to have as you get into a large, diverse enterprise with all these different assets around there and that. So we have that as well. So now what I'm going to do is actually walk you through kind of what we refer to as our day in the life scenario, where we walk through that model life cycle. I showed you that abbreviated one, but just to give you the idea of even in a simplified process like that, how many different players there are and how many different steps and how do we get them all to communicate and make sure models don't get lost, because we find sometimes models get lost in the process. People don't know the assets associated with them. They don't know they've gone bad. They don't know who to contact when something goes bad. So how do we be that conductor of the orchestra and pull them all together to make sure that we have a successful deployment of the model ultimately, and more importantly, after deployment, we keep track of this thing to know what's going on. So we're going to look at that exact scenario today, which is we've been running that back test, you remember in the back that's running and checking for new data. Well, it's using decision tables, DMN in specific, that to basically allow us to describe conditions that it should fail on, because often you see things where it's like everyone just looks at accuracy or something like that. The reality is you're going to need to compare false positives versus false negatives versus F2 versus etc. So you're going to have to take a variety of those into account. So we do that through decision tables and then being able to parameterize those and associate that with a model. So we're going to look and we can see. First, I'm going to switch roles a bunch of times here, but just in the interest of brevity, I'm not going to log in and log out every time. So it's all going to go to the same user, but I'm going to point out when I switch those roles on that kind of thing. So the first one is I'm the model ops engineer, as we refer to it. They're responsible for numerous models from many different business units across an entire organization, but they need that consistent view across all of them to make sure that these business values are executing correctly. So we can see that we've received some alerts. And we actually have seen that a back test has actually failed with a specific reason. Now, we can go in and look at that, and we can see, in fact, that here's our test results that actually occurred. We have the raw test results, but also if we know what kind of a test was run, we'll draw it pretty on here so we can see that things. But again, I'm the centralized person. I don't know what this means. I can see it was actually a new file that was added. It was the last changes that were made to this file. I mean, I could look at the source, but again, I'm not going to particularly be able to do anything about this. So I need to get that out to the engineers, data scientists to actually look at and review and address. So I have the ability to just basically assign it. And once I do that, it's actually going to go off and it will, may take a second here. It will actually create a Jira issue for them on that kind of thing. So let's give me 1 second for it to refresh here. There we go. Come on. Everything likes to run a little slow here sometimes. Hey. Come on, Jira. Give me 1 second here. Give me 1 second. There we go. That's running a little slow today. So we can see it actually got out there. It created a ticket in the assigned project by utilizing the information in the model metadata to determine what product it should actually do. And we can see that that's actually been created within that. So now we know I'm going to go ahead as I'm switching roles. I'm now the data scientist who's in this Jira project. I go actually assign that ticket out to me. But now I can actually go and take a look at this item. So we're going to go out here. I can actually take a look at the test result that actually caused this ticket failure and go in there and take it. It'll take a second to load here. So I have that information and I can remind myself of what it specifically was, that thing. So I can remind myself that was that new file on there. I could go back and review the overall model if I had any questions there on that kind of things on that, and see the other test results if there was additional ones, do some comparative. But in the long run, I'm ready to do this. So I'm actually going to go ahead and start working on this model. Now, working on this model doesn't necessarily mean fixing this particular model. We may choose to push up a new candidate that we believe would work better. And we're going to do that in this case, but we're going to go over to Jupyter because we've actually been working in Jupyter. I'm just going to refresh that. What we've done at ModelOp is actually go in and add extensions to Jupyter. So you'll see that there's some ModelOp Center services to make it easy to interact with our system to be able to pull information in and out on that. So we're going to go ahead and open up a new notebook here. Go and grab that. And within that notebook, we can see we've got the extensions to communicate with the ModelOp Center. So I know I've been working on a new version of a model out there that rather than being an XGBoost model is actually a lasso model. and we're going to grab that one, and that'll actually come down into our system, and that's pulled right from our abstraction back into a notebook abstraction, so we can consistently work on it no matter what the technology we choose to use is. Maybe we make, we're going to go ahead and just make a last minute very significant change here on that kind of things, and we can sync back up with ModelOp Center. It'll tell us the changes we're about to make, and we can go ahead and put those items in and continue to make whatever updates we want. I'm just going to switch screens here because this happens a little fast here. So give me 1 second to things. So now we're going to say that, yes, our model is actually ready to go out there. We believe we've done the fix, we've addressed the ticket. So we're going to go ahead and actually submit that model as a model version. And we're going to go ahead and click that. It'll tell us the most recent changes, associated things. We can see we actually have the source code asset that's associated with it and these changes we're going to make. We're going to go ahead and click that in, but when we do, what's going to happen is it's actually going to go out, automatically run those unit tests we talk about. We're going to actually go through, actually generate those test reports for review, and then actually schedule a review for that. And once again, rather than being all in our system, we've integrated with Jira. And let's hope this one goes a little bit quicker. Yes, it did this time. We can see we've received a new ticket now. So again, we've switched roles. Now we're a reviewer. In reality, this would go to a different project, but I don't want to keep switching projects on that kind of things. It would be a different set of people. So now I've received my ticket to actually go ahead and review this. So I'm going to go ahead and mark that. I should assign it to myself as well. And we can actually go through and say, okay, well, what were the test results that we just ran? And remember, those ran in a known environment against known data and known items. So, that's all reproducible. So we can do that. We can see that we got these new test results. We can also see the most recent changes that were actually made to that model. We could review the source code if we wanted to on that kind of things. And we could look at the model. Now, one of the items in the model we capture is that little plugin in the background actually went out and queried the Python kernel and grabbed all the information about the exact packages that were used within that model. So I can review those and make sure that they're compliant. And I can see every single model that was actually installed on that platform, whether it was imported or not. So again, I can do compliance checking against that if I need to as well, or just at least know what this model actually requires before it actually gets deployed out there to make sure that's all good. So that's all automatically done with that simple submit we did. The data scientists didn't have to do any work to do that. We just pulled all that for them when they submitted the model. But what I really care about is, well, what about the comparative models? So we can see that it's identified that we were replacing this Enron Ecom XGBoost version with this Lasso version. We're going to go out and actually take a look at, did we actually fix the problem? Did we make the solution better? So we're going to do a champion challenger comparison between the two models where we have the test results. In fact, if there are other test results for those models, we could add those in as well, or select or deselect them. But we can see, for instance, we actually decreased our accuracy as being the challenger, but that wasn't the score we primarily were concerned about. We were actually concerned about that F2 score, and we did successfully increase that. We can see we didn't introduce any additional bias. We can see the overall confusion matrix looks fine. And this particular model actually Shapley can be run on, whereas XGBoost actually kind of munges the names, so you can't do that. This one we can actually do some interpretability on as well to see what is contributing to these particular predictions. So we have all that information at hand. We've seen that the results look great. Looks like our challenger is in fact better than the champion that we're attempting to replace due to that failed back test run. So we can go ahead and move it on. Let me drop back here real quick. So remember, now we're saying, yeah, once we actually go ahead and approve that model, so we're going to go ahead and just in our workflow, we're going to go ahead and say, yep, looks good, all done. And when we do that, in the background, it's actually going to pull. It'll take a second to do that. And we can see now it's going out and actually deploying onto the engine. That's all just done through Jira. We don't, again, require you to come back to our system to do that. That's an enterprise integration with systems to use the systems you already use to accomplish these tasks. So now we're going to switch role. Last time we're back to that original excuse me, ModelOps engineer, ModelOps engineer. Yeah, excuse me, a little tongue tied there. Now I want to go out and actually say, hey, what's been going on in my systems there. So I'm just going to refresh that. We'll see that actually we received a new engine notification that basically a model has started to run on an engine. So I want to go out and actually say, hey, what's that doing to my system? So I can go out there, I can see the impact on the overall system and what is going on. I can see how much memory it's hitting. Now this one's tied to a RESTful endpoint, so right now it's not processing any records, but if we were to hit it with that, we would get that. But more importantly, I can see the full journey that this model took to get here. We can see the tests were run. We can see the individual test results. We can see the Jira ticket that was created to actually go do it. So we could go track all that. We can see ultimately who actually did the approval on that Jira ticket to say this model is ready for production to go out there. Plus we can go back to all those test results and everything we've seen out there and kind of run that full end-to-end solutions. We have that full governance, not only of the real-time stats that we're pulling in about what's going on there, and there's many, many more stats that can be displayed, but we also have that ability to do that. And now this one is sitting here being back tested by that other process that's running in the background. So we know if this one drifts out of alignment eventually when that ground truth becomes available. So we have a lot of control there of doing that, and then new tickets will get created. You can see how many different roles and how many different steps, even for this very, very simplified process, how many different handoffs have to occur. All of that got traced here. So we know they occurred and they went through your normal ticketing systems rather than some out of bandwidth process that's proprietary and not integrated with how people do business. So that kind of pulls it all together there and that kind of things. And that's what's core to this overall solution, is that single pane of glass across the system and the ability to shepherd these models through the appropriate level of process that they have to do in order to get it from basically the model factory and model factories, I should say, because aside we saw 3 different ones today: Git, Jupyter, and Dataiku, and then move it through that business process using your existing investments. And we demoed Jira today to actually do that, and then track it all the way out actually to a runtime. As I said, we've shown 2 runtimes today, but there's many more that are out there. But the one we showed today was running the Python models and tracking that and pulling that all together. So it really creates this great end-to-end integrated solution where we have that kind of information available. And with that, I want to leave time, especially today at the end here, to open it up for some questions or anything people would like to dive deeper on at this time, keeping in mind we're going to have visualization. The order of the courses, we're going to do model catalog. We're going to dive deep on, okay, how did we abstract these? Next one's going to be around designing, is how do you enable models for these runtimes and things like that. And then we're going to go into designing model life cycles, and in the next class after that. And then finally, we're going to go into actually putting all this data and everything you've seen together and this governance information, et cetera, and generating reports about models, how they're performing, KPIs, et cetera, utilizing Tableau to do that and pull all that information together to be able to provide that holistic view within your business at a business level. So with that, I'll open it up for questions.